Hello, and welcome back to the Cole Klein's Philosophy Hour. This is episode 13. Spherical coordinates. So today, can you guess what we're talking about? It's spherical coordinates. So, first, let's talk about coordinate systems in general. So the one you're probably most familiar with is this one, the Cartesian coordinate system named after René Descartes. To express a point in this coordinate system, it's an ordered triplet like that, x, y, z, where your x is a distance from 0, the origin, on the x-axis, y is a distance on the y-axis, z is a distance on the z-axis. This one is pretty easy to understand. Spherical, I like to think of it as an extension of polar coordinates, which are a little less known but still not too difficult, where you have something like this, where this would be your x and this is your y. So this is our Cartesian grid. But if I want to express a point, say this one, in polar, you'd have a radius and an angle theta from the x-axis that turns counterclockwise, like that. So like a point here would be r comma theta, like that. So that's pretty easy. Spherical is this, but basically extended into 3 dimensions. So let me draw this pretty big. So here's our x, y, z. And if we want to express a point in spherical, say right here, it's an ordered triplet, rho, phi, theta, like that. So our rho is this distance here, and then we have like some lines like this. This here is our r from this one. Then our phi, well, just so we're clear, r isn't a point, but it's just, you know, there if you want it. Our phi is this angle here, and then the theta is the distance between the x-axis and the line that makes up our r for the point. So there's theta. So that's not too difficult. Like if I want to express a point, say 2 pi over 2 pi over 2, like that, we would go 2 on the x-axis. Pi over 2 is there. If phi equals pi over 2, it's 90 degrees. And then pi over 2 here is another 90 degrees from the x-axis. So we would go 1, 2 out, and our point would be right there. So pretty easy. So like, if I went to the rho, I guess an uppercase phi is like that, and an uppercase theta is like that. If I went to the rho phi theta frat house, which would look like this, there's the door, and here's some windows, circular windows. This is a sphere, because obviously the rho phi theta frat house is a sphere. If I went to a rho phi theta rager and I wanted to know where the bathroom is, they wouldn't say, like, go down the hallway to the left. They would say, go 10 feet from the origin, then turn pi over 3 from the z-axis, and then turn pi over 2 from the x-axis, and there would be the bathroom at rho equals 10, phi equals pi over 3, theta equals pi over 2. Yeah, that's a funny joke, isn't it? So, what is spherical coordinates good for? It's good for spheres. So like if I want to express a sphere in Cartesian, it's really annoying. X squared plus y squared plus z squared equals rho squared, where rho is the radius rho of our sphere. But if I want to express that in spherical, it's pretty easy. It's just rho equals a constant, where c is radius of sphere. Pretty cool. So this makes a lot of problems easier where they would be impossible in Cartesian. Oh, what's this? It's a perfectly placed problem. So this right here is in Cartesian. It looks really difficult. Oh, oops, I forgot something. Let me finish this problem. I got the problem right here. 3 dz dy dx. Yeah, that's correct. Okay, so this problem is in Cartesian, and I want to do it in spherical because it's actually impossible to do in Cartesian. So if I want to do this, first, let's draw a picture and see what it looks like. So we got our x, y, z, like that. The x goes from -2 to 2, so if we have like a x, y axis like that, -2 to 2. Our y goes from 0 to root 4 minus x squared, which is the top half of a circle like this. This is 2. And then our z goes from root x squared plus y squared is less than z is less than root 8 minus x squared minus y squared. So this right here is a cone, and this is a sphere, radius root 8. So this looks really difficult in Cartesian, and in spherical it's not so bad. So the cone right here is like this. Oh, if I extend that a little more. And then our sphere is like that. So the area we're trying to find is this part, which is like an ice cream cone shape, like that. So we're trying to find the area of an ice cream cone like that. So if I write this in spherical, it's a lot easier. So our theta is a complete revolution, so 0 to 2 pi. Our, what's it called? Phi is pretty simple. If we think about our cone, it's like this with a slope of 1, which means this angle is pi over 4. So 0 to pi over 4. And then our rho is just the height of our circle, or our sphere right here, which we already know is root 8. So this is 0 to root 8. And then what do we put on the inside of our integral? So before there was 3, But when you convert from Cartesian to spherical, you have to do some extra stuff, because when you go from squares, you know, like this, to circles like this, the area gets all wonky. So our volume turns into rho squared sine phi d rho d phi d theta, like that. So we'll just take our 3, pull it out, and then rho squared sine phi d rho d phi d theta, like that. So this integral is not too bad. All right, so our final answer then is 16 pi root 2 minus 1. It looks like a lot of work, but believe me, if you tried to solve it this way, it would be like 5 times more work, and I'm not even sure if it's actually possible. So, moral of the story is spherical coordinates are really cool and they're useful, and I think they should be used for everything. Like, for example, here's the Earth, here's like North America and South America, and here's like Europe and stuff. So here's our Earth. Instead of using lines of latitude and longitude like this, which suck and are annoying and weird, we should just use our phi there. Our rho can measure around the prime meridian, which is like here, or our theta, I mean, can measure around that, so that it makes sense. And then we get an extra layer of information because we also have a rho value, so you can say how high your elevation is. Like if you're in like a city, like here are some buildings and stuff, and then here's a subway down here, a train going this way. If say you're a guy here and there's a guy on the subway, in your latitude longitude coordinates they would be in the same place, but in spherical coordinates there would be a difference of phi, which is just great. We should switch everything over to that, and the world would be a much better place. That's all I got for today. Thank you for watching. Goodbye.